Okay, so 2.7 is called piecewise functions, and piecewise function is kind of exactly how it sounds. It just has pieces of the function. So usually has two or more equations in one, and each piece of the function applies to different parts of the domain. So I have an example, and this is a piecewise function. First of all, you can see that here's the function out here, but within the function, there are two parts of it. So this is one of the lines that you're going to graph, and this is one of the lines that you're going to graph, and then this is how you know where to graph that line. So it's easier just to graph the whole thing, and then we can go back and make sure it only applies to when x is less than or equal to 0. And then after we graph this one, we'll make sure that we only use the x is greater than 0 for that one. So let's graph it and see what happens. Okay, so to graph the first one, you still need to know slope and your y-intercept. So our y-intercept is down 2. So I'm going to go graph it down 2, and then my slope is just up 1 over 1. Up 1 over 1, keep going, and I'm going to draw it in both directions and go ahead and draw my line. Okay, now the next line, we're going to do, I'll do this one in orange. So it says up 1, so I'm going to go up 1, and then it says up 2 over 1, up 2 over 1, up 2 over 1, and I'm also going to go this way, whoops. And down 2 over 1, down 2 over 1. So I've got my two lines, and again, I think it's easier just to graph the whole thing and then go back and look at where we need it. So for this blue line up here, this navy blue line, it says that we only need this line when x is less than or equal to 0. So where x is less than 0, remember, there's the x-axis. We only use it for all the numbers less than 0, less than or equal to. So it means like this part of the line right here is okay, but I would have to erase all of this part of the line because none of those x's are less than 0. See how all of these x's are positive over here? Like that'd be 1 and 2 and 3 and 4. We don't want those for that line. So I'm going to erase that part. So you literally just get to keep the intercept because it says or equal to, and it's only good for that portion of the line. So if I kept going, this blue part here would fit that piece. Okay, so now I go to the orange line, and it says for the orange line, it's only good if x is greater than 0. So greater than 0 means that, again, for the domain, all of these would count as yeses. So meaning like I keep that part. So if it's at the 1, if it's at the 2, if it's at the 3, so I can see like over 1 up. So all of these past here are going to have to be erased because those are less than 0. So I keep my navy blue line down here, and then the orange one here, up here, I have this, I've got this, I've got this, and this one keeps going on forever in this direction. Okay, now, the only thing I have to fix is it says x is greater than 0. See how there's no equals? So what we have to do is we actually have to open up that circle there. So I'm going to open it pretty large so you can see it on the video, but we have to have an open circle. It's kind of like when we did the open circle and closed circle with greater than or less than. It's the same thing, but now we're going to put it on an actual coordinate plane and not just a number line. So this is what your piecewise function would look like. You can see that the bottom portion down here, when x's are less than or equal to 0, it would fit that function. And anytime x is greater than 0, it fits that function. So they're two different pieces of the puzzle, but you have to have both graphed. Okay, so here's another example. Again, there are the two pieces, and you just do them individually. So I'm going to graph that, and I'm going to graph this. So again, first thing I need for my graph is I need the y-intercept and I need the slope. So I'm going to go down 4, put my dot, and then I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And for this, I always go this way too, because otherwise, if I have to erase that part of the line, I might not have any part of the line left. So I just do as many as I kind of can and go ahead and draw the line. Okay, then it says x. So the other line here just says 1x. There's no intercept, so I'm going to put in a plus 0 so I know where it crosses. Plus 0, and then it's just up 1 over 1, up 1 over 1, up 1 over 1. So again, I'm going to kind of draw that in both directions so that I have enough space or enough dots. Go ahead and draw the line. So now I go back, and again, you don't have to do this. You could do this right away. But for the first line that I have in orange here, it says that this is only good for when x is less than 0. So again, this line right here is your x-axis. All the x's over here on this side are negative, and all the x's over here are positive. So if it says that x has to be less than 0, like let's say I win money if I would land on this line when x is less than 0. Well, I go find where x is less than 0, and it's anything going that direction, and it's my orange line. Everything good, everything will win me money if I go to the left. So that means I'm going to erase everything on the right side over here. I don't need that because that's no good. And I'm also going to check to see if it's greater than or equal to, or less than or equal to. Again, it's just less than. So I need to open up that dot and have an open circle on my 0 because it doesn't count 0, it just says less than. Okay, the other green line down here says that it's only good when x is greater than or equal to 0. So again, looking at your x's and your y's, greater than 0 is only good over here because that's my x's where they're positive. So again, I'm going to erase this green line all the way up to the positive. I'll redraw it here. So it's good through there, and then again, I'm going to go back and see, is it just greater than, or is it, sorry about that, is it greater than or equal to? So it says greater than or equal to, so I'm going to leave it filled in, and again, you can see the two different pieces of the piecewise function. So you kind of see two separate ones on the graph. Now, it may ask you to also find a domain and range, and domain and range is just like last time, but you just have to account for both lines. So looking at the domain, remember that's how far left and right this goes. Well, this orange one goes forever left, and this green one goes forever right. And it picks each other up. See how this one's filled in and this one's open? So there's no gaps. So for the domain, it would just be all reals. For the range, you're trying to figure out what's the lowest point and what's the highest point. Well, the lowest point here is right here. See how everything else on this graph is above there? So let's see, that's down -1, 2, 3, 4, but it's open. So you're going to say y just has to be greater than 4. And that accounts for all of this line, and it also accounts for all of your green line. Okay, so the last thing you might have to do is actually write the function, which means they've already given it to you, and you're actually going to have to come up with what it is. So first of all, you can put the f of x equals, or you can put y equals, doesn't matter. And then you just put a little bracket bar, and then you literally just have to find the equation for both. So doesn't matter, you can start with either one. I'm going to start with this one over here. I can see that it crosses the y-axis at +4. So I'm going to put a +4 down there, and then I'm going to count the slope. So it looks like I'm going down 1, right 1, down 1, right 1, down 1, or sorry, left 1, down left, down left. So it's